In this video, we're going to be doing a couple trace recursion bottom-up examples. So let's look at this code here. Public int height t trino t. So this first line, it's going to be the declaration of the method, and this is going to be a method that returns the height of the tree. Here's our base check, and it checks if our node is even in existence, and then what it does. Here we have our integer, and then we have 1 plus the height. So we go back to the function. We have to run the function again. And then t dot get left. So we're getting the left height of subtree. And we're adding 1 to account for the edge and the current node to the left check. Now we do the same thing for the right subtree. And we add 1 to the right child. Now here, math max of left and right. So we're going to take the height of the current node and see if this is the larger of the two subtree heights. Or it is. So let's say that we have this tree. If you have this tree A, B, D, A, B, D, C. First, you're going to start at leaves. So start at leaves. So at the leaves, we can see here that it's null, and then this is also null. So that means that if you do left and right, you're going to have 1 plus -1 and equal to 0, and then on your right you're going to have 1 plus -1 is equal to 0, because -1, when something is null, that means we just say that it's -1, because that's what happens when it's null according to our code. So also for the left, when we have something on the left, it's gonna be 1. So this is our null, or this is here, this is here, and then that's the height. So now we can say that the height of t is gonna equal to 0. So now let's move up to node B. Actually move this down so we have more space. Now for B, we looked at the left height. We have 1 plus 0 is equal to 1, and then on the right we have 1 plus -1 is equal to 0. So this returns, now that we have left and right, we plug that into here. So math max of left and right. So max is going to be 1, 0 equal to 1. So that means the height of B is equal to 1. Now after this, let's do C. This is a leaf. Now for the left side, you have null, and then the right side you have null. So that means that the left is going to be -1, and your right is, or you can just say that it's -1 and that's -1. And then when we're checking for our height, your height's just going to be C is equal to 0. Now, finally, let's do A. So for A, on your left side, your height of B, you're just going to look at B and C's height. So your left is going to be height of B, and we have that as 1. And then on your right, it's going to be your height of C, and that's going to equal to -1. So that means your height of A, you're going to do max of 2 and 1, and the max out of those two is 2. So that means your height is going to be 2. Your max is going to be, whatever your max is equal to your height. So now that's for this code. Let's analyze another code block. Let's say that you have a situation where you have a code that writes the sum of the leaves. Public int leaf sum tree node t. What this method is going to do is it's going to return the sum of all of your leaf node values. If t is equal to null, that checks if you have a node that is equal to nothing, and if your first node is equal to nothing, that means your whole entire subtree is going to be empty. Return 0. So that contributes nothing to the sum. If what you get from the left is equal to null, and also if what you get from the right is equal to null, what we're going to do is check if the current node is a leaf. So a leaf has no leaf and no right child. That means that that's because we checked that if this one on the left is null and the one on the right is null. So that means you're just going to return the value of the leaf because there's nothing below it to get. You can't do get, we already checked if the left and right, if we can get them, and we found out that they're nothing. So now we're just going to return what that node we're actually on is. Return leaf sum t.get left plus leaf sum t.get right. So if it's not a leaf, then you're recursively going to compute the sum of the leaves in the left subtree, and then recursively compute the sum of the leaves in the right subtree, and then we're going to add those. So let's say we have 5. Make this bigger. Let's say we have 5, 3, 8, 6, 10. So what are our leaves here? Our leaves are going to be 3, 6, and 10 because they have no children. So you're going to work bottom up. So at node 3, our leaf is going to return 3. And then at node 6, we're going to return 6. Let's do this in a different color. So this is going to return 3. This is going to return 6. And then 10 is going to return 10. Now on node 8, you finally have something that's not a leaf. So you're going to look at the left and the right. So your left is going to be 6, and then your right is going to be 10. So then you're going to have 6 plus 10 is equal to 16. So then what we're going to return here is where we're going to return 16. So now we look at 5. So on 5, we look at the left is going to be 3, and then your right is going to be 16. So then you have 3 plus 16 is equal to 19. So that means your sum is going to be 19. For that tree. Now we have a customer subtraction pattern. Public int weird tree node t returns special calculated value. So first it checks if t is equal to null, and if it is, then it's going to return 0 so that it contributes nothing to our total sum. So now after this, return t.get value. So we have minus weird t.get left, and we have plus weird t.get right. So what we're doing is we're recursively computing the value for the left subtree. So we're going to the left, and then we're going for the right subtree. So our formula is the current node value. So we have our current node value minus the weird. Minus weird is the name of our method. So we go like back up here, and we go back up here too. Weird t.get left, and then you have plus weird t.get right. So you're subtracting what's on the left and you're adding what's on the right. Okay, so let's say you have a tree like this, like you have 7, 4, 3, and 2. So you're going to start at the bottom. So at the bottom node, you have a leaf or let's just label all the leaves. So for our leaves, we just have 2 and we have 3. So for this, we know this points to nothing, this points to nothing. Connect our tree. So at 2, you have 2 minus 0 plus 0 is equal to 2. So you're going to return 2 here. Now at node 4, you have that your left is going to be 2 and your right is actually null. So what you do is you have 4 minus 2 plus 0 is equal to 2. You return 2 here. Now, what about node 3? It's a leaf. So just like the node 2, you're going to return just the value of it. So it's just going to be 3. Now node 7. Now on the left, you have 2, and on the right, you have 3. So that's going to be 7 minus 2 plus 3 is equal to 8. You're returning 8 for the whole tree. So usually when you're doing bottom-up tracing, takeaways are, first you ignore the first root, then you go to the deepest leaves. Go to the deepest leaves. Always write down their return values, and 4, plug upward level by level. So what your result is from the left on one level, then you look at the right one too, and then you just add those together. And then only then, after you've done all of this, you compute the root.